My name is Shawn. I go by Swix on the internets. I guess I'm known for learning in public. I think that's a motto of mine that I keep sharing. And I started out as a Jamstack skeptic. And this is a little bit of my journey as sort of discovering why people care, why is this such a big deal. And I'm just sharing my reasons for it here. I'm also a moderator of the r/React.js subreddit. If you work in React, if you are interested in React, there's 140,000 of us discussing React, so you're welcome to join us. And I guess most relevant for this talk, I also work at Netlify, which is a very strong proponent of the Jamstack. In fact, it's all in on this Jamstack idea. So we'll talk about what that means. So Jamstack, what does it stand for? It's actually an acronym. It stands for JavaScript, APIs, and Markup. And we'll sort of break this down, but it's the whole idea that you should ship your app, your site, as static assets. You pre-build all the stuff that you want to do, and then you ship it out to the CDN, and it serves it to your users. For anything dynamic, you hit APIs, and that's it. There's no running server to run, maintain, scale, pay for. So the more discerning of you would be skeptical, like I was. Like, shouldn't this just be another word for static sites? Like that's been with us since the dawn of time. And there is some truth to that, but then there's also some differences. And I think I'm just gonna explore those differences, and hopefully you'll join me in this journey. And in fact, Chris Coyier actually picked up on this. He actually said, like, JavaScript's not a priority here, API is not a priority here, Markup's not a priority here. What really matters is static hosting, and he called it the Shamstack, which is a sort of clickbaity title for this. And we'll talk about why this is true in so many ways. And if you're a developer, you're already like up to here with all these stacks, right? There's just so many stacks that we're used to encountering. And all of them say that they're the best. I think the thing that sets Jamstack apart from all of this is that it removes complexity instead of adds complexity. And I'll try to back that assertion up. So in the beginning, as you all know, like the original World Wide Web page from CERN was just a simple static file, and we served it from an actual server. As time goes on, we immediately want to serve it to browsers, and that browser section will proliferate. But this is the rough model, right? Like you author in something like an editor, you output an HTML file, and then serve it to the browsers. Where it starts to get complex is when you start to need dynamic behavior. And at the time, we didn't have the very complex JavaScript that we have today. So the only way to solve this was to add programs behind the server to actually introduce that dynamic behavior. Once you need a program, the program needs to remember stuff, so you also need to add a database. And as this machine scale, as the number of users grows, this starts to have scaling issues. But all in all, like there are many different approaches to this. The most successful one was the open source stack, which is why we're all here, and that came to be known as the Lamp stack. And this is still the dominant paradigm of serving websites today. That you author something that's a running program, you run that server, you manage that server. On request, the server generates HTML, serves it to the browser. The browser requests the next page from the server again, and so on and so forth. That's the cycle of the server-side generated pages. And there's some problems with this. So first of all is the problem with scale, right? It's fine if like you have you and your mom like visiting your personal blog, but as you scale to like 1 million people, then you start to need caching layers. You start to need balancing layers in between different instances. And this adds extra complexity and cost that you have to pay for in terms of either dev time or your personal wallet. And so there's one optimization that is that's pretty neat. We start to put CDNs in front of our servers, and that is a nice static layer that buffers that. And so the argument is like, why not just put everything on the CDN layer? And that's what we're going to explore later on. But traditional stacks, we add static layers, we add infrastructure in order to improve performance. We have no other solution because we're just predicated on this one assumption of a running server. So the only way to improve that performance of the running server is to just add ways to scale it and to not do work by essentially cheating. We'll still cheat. We'll cheat in different ways. And there's a number of problems all to do with sort of infrastructure, ensuring availability, migration, auto scaling. All of this stuff comes with managing like a site at scale. And this is all, if you're someone trying to build an app, if you're someone trying to serve a site to users, this is not something you set out to do. It's just something that you run into as you try to serve your users. And that's what we kind of call accidental complexities. Like, it's not really what we signed up for. It's the stuff that we have to deal with in order to get where we're trying to go. And so I kind of boil all that sort of number of different problems down to just 3 that's more manageable and easier to remember. So it's security, reliability, complexity, and alongside of that is cost. There's also the talk about the mean stack, and this is sort of JavaScript eating the world. We had the rise of front-end frameworks rising up over on the front end, and then we looked at the back end, and we were like, okay, let's make those JavaScript too. But we didn't really solve anything. We just rewrote everything, and now, like, the main benefit is if I know one language, I can now be full stack across all of them. And that's the promise of the full stack JavaScript, and the term was coined by Val Karpov, actually 6 years ago now. So not too old, but not that recent. And now we call it the mean stack. The primary addition to this stack is a sort of optimization around client-side rendering and routing. So the idea is being that you deliver a fat bundle of JavaScript, and then you only traffic in individual data pieces instead of full HTML chunks when you navigate to the subsequent page. And so that's obviously a nicer experience for your users. The problems with that, we've basically taken all the LAMP stack problems, rewritten them in JavaScript, and then added an extra thing of performance. And that's where front-end JavaScript bundles kept growing bigger and bigger and bigger. If you take a real-world sort of budget to this, someone's done the math. Alex Russell from Google has done the math. And it works out to around about 130, 170 kilobytes of critical path resources on your first load. And if you take that math and you sort of map it out, we actually crossed that roundabout in 2011, and the growth of JavaScript on the web has continued to grow since then, pretty much unchecked. So we, and the primary sort of culprit of this is single-page apps. Like this is the default output of Create React app, where the first thing you see on loading a page is a blank page, because all you do is serve an empty div, and then you use JavaScript to fill in all this other content, and then something shows up on the screen. So it takes, especially on low-power devices, it takes a long time for something to be interactive and to be painting on the screen. So that's the model of client-side rendering, and obviously we're not super happy with that, but that's what we are stuck with today on the mean stack. We have managing the server stuff, and we're also managing the JavaScript stuff. Is there a better way? Probably. One of the reasons it's slow is because of all this sequence of stuff that has to happen before our user can actually see our site. Like, we have to request the HTML, then we have to request all the resources that HTML links to, and then we decompress and compile and render, and then we actually make our site interactive. So one of the performance optimizations was to actually flip this and try to do all that work up front of rendering the HTML before inlining styles and SVGs, and then the client, especially a mobile phone, can just show that site. And then you load all the subsequent resources like JavaScript, CSS, and images. So that's what we call server-side rendering. It's a lot faster, especially for the overall time to interactive. And that's the sort of current paradigm in terms of state of the art in terms of how server-side apps and sites are rendered. Still, you're stuck with this paradigm of either you do client-side rendering or you do server-side rendering. They're fairly large architectural decisions, and they're very binary in terms of the way that you approach them. And their trade-offs may not be acceptable to some people. So we'll explore how to do this without servers. Like, that's the whole point. We want to do away with the complexity of managing servers. I'm going to take that and freeze it, and I'm going to talk about the environment around web dev that's also happening around this last sort of 20-year period that we're exploring. What else has happened in this 20-year period? Git became a thing. I can't imagine a time when like Git is so central to our workflow right now that's something that doesn't have to be sold. We actually at Nullify call this Git-based workflow, where we now expect continuous deployment whenever we check something into Git and it's valid code, we want it to be deployed, so we can do continuous deployment. We also have some standards that are now industry standards, like every commit having an immutable deploy, so you have a reference to it. You can always check. You can check it if you make a PR, you can check a deploy before you merge it in to production. So you have all this automated tooling around how you deploy. Second trend, the API economy also sprung up. So these are companies that are they're serving developers. They don't serve end users. So all of this is functionality that you used to have to write yourself. Like you used to have to write image optimization and file serving code. Now you just use Cloudinary. Same for Twilio and basically every sponsor out there. This is the API economy, which means that a lot of this functionality that you used to have to hand code that everyone else did as well, you no longer have to do. So you focus on the thing that makes your app, your site special, right? All of this is just commoditized. Third trend, we'll talk about the Jamstack landscape. That's the API economy plus all these other services that have been brought up. So these are two. Here's a chart. Here's a Jamstack landscape chart from one of the investors, the venture capitalists interested in investing in this landscape. And there's another one just to show you even more logos to confuse you. but I just want to give you the idea of the breadth of number of players and the breadth of them in this ecosystem. I actually just published this morning a Jamstack for indie hackers. So if you're a bootstrapper, you don't want to go after venture capital and you want to make money serving the Jamstack developers, that's a good guide as well if you want to check that out. I'm pretty passionate about indie hackers. Third trend, serverless. Amazon launches this in 2014, closely copied by Google and Azure. But broadly, like it's now no longer a question that you can run production workloads on serverless, right? Like there's all these financial companies running trillions of dollars, trillions of requests a day on serverless. So that enables a lot more things that can be done without a running server, without managing your own server. You can just put a lot of arbitrary logic on serverless. Fourth thing, build tools. We have all this wonderful build tools covered by Ben in the earlier talk. I'm not going to go through all that because we don't have time. But these are just like increasingly professional ways of building and delivering JavaScript applications. Fifth trend and final trend is static site generators. There's a resurgence in static site generators that we've been tracking since 2015. It's not just typical static site generators like Hugo and Jekyll, but also newer versions of newer sort of JavaScript-enabled, I'd say, versions of static site generators like Next.js and Gatsby. And so there's this whole new generation, and what they do that's different from the previous generation of static site generators is that they render out all the HTML beforehand, but they also ship a JavaScript bundle that makes it interactive and makes it into a client-side app, and it sort of hydrates your whole app after you sort of send it to your users. And so that introduces a more performant and simpler third dimension, which we call static rendering. And that does the least amount of work because you're basically cheating by moving that work to a build step instead of doing it on request. Does that make sense for your application? Only you can decide, but it does make sense for a lot of people. So now you have this whole spectrum because of the flexibility of JavaScript to render a shell, render individual components, to pick and choose as much dynamism as you want. I highly recommend checking out this article, Rendering on the Web, from the Google DevRel team, to really explore this as you sort of think about your architecture for your client-side and server-side apps. So what is the summation of all these trends, all this increasing sort of movement in JavaScript? What is the summation of that? And that's where I come to the Jamstack. So I think I wasn't really sold until I understood that this is the culmination of all the trends that are going on in the web dev space. So if we really look at the current definition of a Jamstack, it's a modern architecture for creating fast and secure sites and dynamic apps with JavaScript APIs and pre-rendered markup served without web servers. So that's the core thing that you're serving. It's capable of being served from a CDN. That's the insight that Chris Coyier had, that everything can be CDN hosted. And the other key thing that I should point out is that it's an or and not an and. So you don't have to use JavaScript if you don't need it, but it's there if you want it, and it's there for you to progressively upgrade your functionality as you proceed in your development of your site. So Jamstack means capable of being served directly from a CDN, and that's a fantastic implication for cost, security, reliability, all that good stuff. What are the scope of static site generators? So this, the stuff at the top I've sort of listed as sort of first generation static site generators. And the second are more tied with JavaScript frameworks. It's up to you to choose based on your needs and the preferences of your team. We don't really sort of impose which one you should choose. But obviously you can do more with JavaScript if you choose, and that's what I do. What are Jamstack hosts? So Jamstack is not Netlify specific, even though I work there. I do like to promote other ways of you doing it. Obviously, the first progenitor of this is GitHub Pages. Tom Preston-Warner is also a big Jamstack fan. But you can host it in an S3 bucket. You can host it on a Raspberry Pi. You can host it on Zeit, AWS, or Netlify. It doesn't really matter, and that's the whole portability of it, because you're only just serving static files. And therefore, you're not building any of these assumptions which might go away. So it's a more robust assumption because it's a tale as old as web development. Who uses Jamstack? Open source frameworks, venture capitalists like Sequoia. Smashing Magazine is like a giant magazine. And they're all using Jamstack, including Citrix, Trinet, and PayPal, which are all Jamstack users. I like to actually talk about Netlify as well. Netlify's app is also served on Netlify, and a lot of people are surprised by that. They're like, you can do all this like authenticated, dynamic, API-driven stuff, and I'm like, yeah, and it's absolutely fast and easy to maintain. I also like to bring up PayPal as an example. PayPal.me is on the Jamstack, and they're not Netlify customers. In fact, they actually had financial certification requirements, so they had to build their own Jamstack infrastructure. So I like to bring this up because it shows that it has independent value apart from buying into someone else's infrastructure. You can build it for yourself if it makes sense for you. So definitely check out this talk if you're interested in building it in your enterprise. I think less, I don't want to emphasize this too much, but I think the developer experience is also worth talking about in the fact that the way that you develop locally, you just check, it's mirrored in the way that you deploy. And the only thing connecting them is the way that you check your code into Git. So the way that you deploy and build is the same way that you develop locally. And I think that's a very nice debuggable developer experience. And I have a lot to say about that, but I don't have time. This is the only Netlify-specific slide in the entire talk. So Netlify is Netlify lives and dies on serving the Jamstack developer, and the whole company is predicated on if we assume that you do static site generation, what can we provide you? So we provide you things like instant rollbacks, deploy previews, branch functions. One of the things I like to talk about is analytics as well. Because everything is served from a CDN, we actually provide server-side analytics that cannot be blocked by client-side sort of ad blockers, because literally if you're requesting the file, we have the logs on your requests. And we can show you that analytics as well. So that's been a very successful launch for this year. Yeah, so let's do a quick recap. Where do we come from in terms of all of this? Like the open web is under threat. The usage of mobile over desktop has been taken over, I think, in the past 2-3 years. And of mobile, most of it is just native app. And so we really need to innovate in terms of the way that we deliver our websites and web apps. And it's probably something like a Jamstack, something like a progressive web app. And this will be the way that we try to fight for the open web. And so my answer to the opening question about how do we deliver our sites is that we should deliver it the same way that we deliver mobile apps. We should build from source code into static assets, and we should serve the static assets from a CDN. And that's for me, like that was the point at which I converted from a Jamstack skeptic into a believer. So that's my entire talk. If you want to get the slides, ask me questions, I'm going to stay behind after. But thank you so much for your time.